Hey you guys, this is Mr. Millings, and in this video we are going to be doing some advanced Charles Law calculations. So hopefully you've already watched the very first video on Charles Law basics. So let's jump right in and take a look at an advanced Charles Law calculation. In this example problem, it says initially 2.42 moles of argon gas at a temperature of 0 degrees Celsius is placed in a container. If the temperature of the gas changes to negative 132.9 degrees Celsius, then determine the final volume of the gas in liters, and we can assume a constant pressure of 1 atmosphere. And so there's a lot going on in this problem, and basically what's happening here is that we have a gas, in this case argon, as an initial temperature. We're going to put it into a container, and then the temperature of the gas is going to change to negative 132.9 degrees Celsius, and we're asked to figure out the final volume of the gas in liters. And so if we start to take a look at this problem, we can see that this is a Charles Law problem since it deals with volume and temperature. In an earlier video, we learned that the initial volume divided by the initial temperature is going to equal the final volume divided by the final temperature. And don't forget, of course, that when working with Charles Law, that the temperature needs to be in Kelvin. And don't forget also that the volume units are going to have to be the same. If this is in milliliters, then this needs to be in milliliters. If this is in liters, then this needs to be in liters. But our question is asking us to find V2 in liters. So how can we solve this problem? Well, let's go ahead and start by first labeling the different variables. If we take a look here, we have an initial temperature of 0 degrees Celsius, right? It says initially 2.42 moles of argon at a temperature of 0 degrees is placed in a container. So initially, that is to say, first, the temperature we can see is 0 degrees Celsius, and very first thing we have to do is convert this to Kelvin. So we're going to go ahead and add 273 to this, and this is going to give us our Kelvin temperature. So our starting Kelvin temperature here is 273 K. Let's read on. It tells us that we're going to place this in a container, and then what's going to happen to the temperature? The temperature is going to change. The temperature, it appears, is going to change to negative 132.9 degrees Celsius. Let's go ahead and convert that to Kelvin first by adding 273. And when we take negative 132.9, and we add 273 to that, we're going to end up with 140.1. So we know that T2 is 140.1. We're asked to determine what the final volume is in liters, right? We want to figure this out in liters. So what's missing from here? Well, we have to figure out what V1 is. V1 is not given to us, right? V1 is not given to us in liters, but what we do know is the number of moles. It tells us the number of moles here is equal to 2.42 moles of argon gas initially. So how can we figure out the volume based on the number of moles of argon gas? Well, there's a couple of different ways to do this. I'm going to show you the way that we can use the density formula to calculate what V1 is. But understand that we have to figure out volume 1 first before we can solve for volume 2. So if we take a look at this problem here, it tells us that we have a number of moles of argon equaling 2.42, and N stands for the number of moles. So the very first thing we're going to do is we're going to convert this to mass or grams, so that way we can use the density formula to figure out the volume. So we want to cancel out moles of argon. We'll put that at the top. We're going to convert this to grams of argon. So we're going to put moles of argon on the bottom. We're going to put grams of argon at the top. And then if we look on a periodic table of elements like the one that just popped up in front of you, we can see that 1 mole of argon is equal to 39.95 grams of argon. This is now going to cancel with this unit here, leaving us with grams of argon. And so now we just take 2.42 times 39.95, and we end up with 96.7. But now we just know the mass. This is equal to the mass of our argon. What we need to figure out is the volume. So what we now have to do is use our density formula. We know that density equals mass over volume, and so we want to solve for V here. So we're going to get V all by itself on one side of this equal sign by first getting rid of the fraction. And so this is going to leave us with volume times density equaling mass. We're now going to divide both sides by D. D is going to cancel. And so to get the volume here, we're going to take the mass and divide it by its density. So what is the mass in this problem? The mass we just figured out is right here, 96.7 grams, and we're going to divide this by the density. And if we take a look at some sort of density table like the one that just popped up in front of you, we can see that the density of argon is equal to 1.784 times 10 to the negative third grams per milliliter. And so this unit's going to cancel with this unit, leaving us with milliliters. And when we put this in our calculator, when we take 96.7 and we divide this by 1.784 times 10 to the negative third, we're going to end up with, and I'm going to put the answer in scientific notation, 5.42 times 10 to the fourth milliliters. So we finally figured out the initial volume. It's 5.42 times 10 to the fourth milliliters, but we need to figure this out in liters since our final answer is going to be in liters. So what do we have to do here? Well, we have to do some dimensional analysis, and we're going to go ahead and just do this up here. If we take a look, we know that the volume, or V1, is equal to 5.42 times 10 to the fourth milliliters. We want to cancel out milliliters and we want to convert this to liters. And so we know there's 1,000 milliliters in 1 liter. So when we take 5.42 times 10 to the fourth and we divide by 1,000, we end up with 5.42 times 10 to the first. Liters. So we had to do all of this work here just to figure out what the volume is. So we just figured out the volume. We saw, or we just calculated rather, that the volume, or V1, is going to equal 5.42 times 10 to the first, which is the same thing as 54.2 liters. So now that we're done doing all of this, we have both temperature units in Kelvin, we have volume in liters, so our final answer will be in liters. We can now start to plug this into our formula. So we know that V1 over T1 equals V2 over T2, and so what we can do is we can cross multiply to get rid of the fractions. Since nobody likes fractions, let's just cross multiply to get rid of the fractions. And so if we do that, we'll end up with V1 times T2 equaling V2 times T1. In this problem, we're now trying to find V2, so we're going to divide both sides by T1. T1 is going to cancel, and so the formula that we're going to use, and we'll go ahead and put this down here, the formula that we're going to use to solve this problem is going to be V2 equaling V1 times T2 all over T1. And so what is V1 in this problem? 54.2 liters. What is T2 in this problem? 140.1 K. What is T1 in this problem? 273 K. And so now we can put this into our calculator. We're going to take 54.2 times 140.1, and then we're going to divide this by 273, and we'll end up with 27.8. 27.8 what? Well, Kelvin cancels with Kelvin, leaving us with liters. So this is going to be our final volume. This is V2. And so does this answer make sense? Well, let's take a look at what's happening here. If we take a look at what's happening, we can see that the temperature is going from 273 to 140K. So this right here is about half of this right here. So what should be happening to our volume? Our volume should be about half of the starting volume. And in fact, 27.8 is approximately one half of our starting volume. So that's an advanced Charles Law calculation. There's a lot going on, a lot of unit conversion, but that's how you do it. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner. That will subscribe you to my channel, and feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.